Lesson 5.3, radical equations. We learned to solve polynomial equations in lesson 5.1. We did rational, things with variables in the denominator, in 5.2. Now we're going to look at radical equations. Again, these are all types of functions that we talked about earlier. And in the next lesson, we'll work with exponential and logarithmic functions or equations. But right here, we're doing radical equations. Radical equation is an equation containing a variable as part of a radicand. So a variable within a square root or cubed root or fourth root, whatever it is you're dealing with, a variable inside there. To solve these radical equations, we want to isolate the radical and then raise both sides to a power. Now, if there's more than one radical, isolate one of them, usually the more complicated one, raise it to a power, and then do it again, isolate the next one. If you have an even root, like a square root or fourth root, remember you can't have negatives under there because you end up with imaginary numbers, and we're not dealing with imaginary numbers right now, we're just dealing with real numbers. So make sure you check your answer, make sure it works, and it doesn't make what's under the square root or fourth root negative. Remember, if it's an odd power or an odd root, it's okay to have a negative. And we will end up squaring both sides, and when you especially square both sides or cube both sides or raise something to a power, you could come up with what are called extraneous roots. So make sure once you find your solution, you go back and check your solution. So let's go through a couple examples here. You'll see examples like, these are examples of one that you'll see on homework and tests and quizzes. So we want to solve this equation. If we follow our steps, we want to isolate the radical. To do that, isolate means get it by itself, so we're going to go ahead and add 1 to both sides. And we get the cubed root of x squared equals 16. Well, to undo this cubed root, the inverse of cubed root is cubed, so we're going to cube both sides. Obviously, 16 cubed is 4,096. I'm sure you all know that. And then you can take the square root of both sides. Make sure you do plus or minus. The square root of 4,096 is 64, I believe. So you get x is plus or minus 64. It does make sense. We can have a negative under here, but what ends up happening is it's squared anyway. So 64 squared is that 4,096. Cubed root of that is 16 minus 1 is 15. So our answer, you get two solutions, plus or minus 64. Now this one we want to solve for x. We have x minus 5, square root of x minus 5 equals x minus 7. Our first step, again, is to isolate the radical. Well, the radical is already isolated. It's here on the left side. Nothing else is with it. So now we can square both sides. Square the left side. The squared will cancel with the square root, and you'll be left with x minus 5. You square the right side. It means you're multiplying x minus 7 times itself, and I know some of us still struggle with just squaring both of these. That is not the correct way to do it. Square x minus 7, so that's x minus 7 times x minus 7. Please get in the habit of doing it that way, and then multiplying that out, you get this. Now what we're going to do is we're just going to solve for x. So we can get everything to one side. I would probably subtract x and add 5 to both sides. So subtract x gets us to negative 15x, and add 5 is 54. Now thinking through this, can we factor this? factors of 54 that add up to equal 15, 6 and 9. So x minus 6 times x minus 9. And so either x equals 9 or x equals 6. Now both of these are okay for not making a negative under the square root. Now let's go ahead and check our answers. We'll go ahead, we'll plug 9 in. 9 minus 5 equals 9, or square root of 9 minus 5 equals 9 minus 7. 9 minus 5 is 4, square root of 4 is 2, 9 minus 7 is 2. And so it works there. So 9 works. Now check 6. Square root of 6 minus 5. We want to check, does that equal x minus 7? Square root of 1 does not equal negative 1. So that's false, which means 6 is not one of our solutions. So our only solution to this is 9. So again, there is an example where you see the importance of checking your answers. And the next one here, the last one, looks pretty complicated. We have two radicals. So what we want to do is we want to isolate one of them. And usually we choose to isolate the more complicated radical. So we would isolate this one here, square root of x squared plus 5x plus 3. We do that by adding this to both sides. I'm not showing all the work. Hopefully by this time in your math career, you're okay with adding this to both sides. You would get what's over here on the right side. Now we're going to square both sides. Squaring the left side's easy. Squaring the left side, it would cancel with the square root, so you're left with x squared plus 5x plus 3. Squaring the right side, we're going to have to multiply that out. So this whole thing squared means it times itself. You do this distributive property. So this times this would be the square root of x squared plus 3x squared. So when you multiply those, the square root would cancel with the squared. Then multiply here, here, and then last you would do 1 times 1. So again, this term, or these two terms come from multiplying the first here times this first. Multiply this times 1 and this times 1, so you have two of those, and then 1 times 1. Now we have a radical still, so we want to isolate that radical. So we're going to subtract x squared from both sides, subtract 3x from both sides, and subtract 1 from both sides. So subtracting x squared, that will be gone. Subtracting 3x, that will be 2x. And subtracting 1, that will give us 2. We want to isolate the radical, so let's go ahead and divide here by 2. Both sides by 2. And now we can square both sides again. Please be careful with that left side. That's going to be x plus 1 squared, which is x plus 1 times x plus 1. On the right side, the squared will cancel with the square root. You'll be left with this. This is what x plus 1 squared is equal to. And now we solve. Just taking a second to look at it, I would subtract x squared from both sides. That would eliminate those. And I would probably just subtract the 2x from both sides. And we would get x equals 1. We want to check our solution. Plugging 1 back in there. 1 squared plus 5 times 1 plus 3. And so we're plugging 1 in for x. So we would get this. This would be 1 plus 6 plus 3. Sorry, 1 plus 5 plus 3, which equals 9. This would be 1 plus 3 is 4. So we have the square root of 9 minus the square root of 4. Well, the square root of 9 is 3. The square root of 4 is 2. 3 minus 2 is 1. It does work, so our solution is x equals 1. So that is lesson 5.3, solving radicals. Um, Remember, follow through those steps, isolate the radical, raise both sides to a power, and then solve for the variable. That's it. Please, again, use your time wisely to work on your homework. Um, that's it.